Wait a minute. Okay, so it's question 7.
Yes, sir.
Right, so a woman decides to have children, and she decides to keep on having children until she gets a boy, or she's going to give up after 4 children. Whichever of these things comes first. Obviously, if she gets a boy, she'll stop, but if she keeps getting girls, she won't. Let X be the number of children that she has. Okay, so that's going to be for the table in part B, so I don't need to worry about that right now. For simplicity, assume that the probability of a boy is 0.5. I know in other questions that number has been like 0.52 or 0.53, I think, right? But for this time, it's now 0.5. And they give you a list of all the things that could happen to that woman. So I'm just going to write them down, then I can return to my screen. So the first one is she has a boy as her first child. Okay. And the next event is, well, she had a girl, and then the second child was a boy. And then the next event is that she had a girl, then another girl, and then finally her third child was a boy. You see that she would stop then. Now, this doesn't keep going forever, but it kind of feels like it might be. She has 3 girls, and then finally she gets a boy. And then she has 4 boys. And I'm going to share a little story with you here. One of my many siblings, my sister Morag, wanted a girl, right? Always wanted a girl. That was what she wanted. And she kept trying to have a girl. And she got 4 boys, and then she gave up. So it can happen, right?
Yeah.
She did it the other way around. And just to prove genetics is weird, all of her boys, their first child was a girl. So go for it. There's no rhyme or reason to probabilities. Right.
Picking up where she left off.
Yeah, probably. So she did get lots of girls. They just happened to be her grandchildren, not her first germ. So I'm now going to show you what these probabilities would look like, how we would calculate them. Because essentially, we're going to be doing a lot of multiplication. So the first one is a half, but I'm going to call it 0.5, right? Now, what about getting a girl first and a boy? Well, they're independent of each other. So because they are independent, I can just multiply the 2 probabilities together. And a girl is 0.5, and a boy is 0.5. And so that gets me 0.25. Now, what about this one? Well, that's a girl times another girl times finally a boy. But every one of them is 0.5s. And that ends up being 0.125. Do you see where this is going?
I do.
So the next one, girl, 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 boy, that's going to be 0.5 to the power of 4. Boy, 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 boy is also going to be 0.5 to the power of 4. That's a much quicker way than saying 0.5 times 0.5 all the time. So 0.5 to the power of 4 is 0.0625 and 0.0625. Right. So far, so good.
Yeah, but that last one should be 3 girls. Or I'm sorry, 4 girls.
Oh, you're right. The good news is it's the same answer, so I don't need to change the answer. So that's 0.0625. And that's the end of that part of the question, right? Now, we still have a second part, which is this funny little table. It's called a probability distribution table. So it's called the probability distribution table. And what this table does is that you write down all the things that could happen in this story and the probability of it happening. So X is the number of girls, right? And then underneath, the probability that you get it. So you could have one girl. Well, actually, you could have 0 girls, 1 girl, 2 girls, 3 girls, or 4 girls. I believe that's what the table looks like, doesn't it?
Yeah.
Okay. So what we need to do now is figure out where the probabilities for each of these things, how we get them, right? Well, let's look at 0 girls. So if she got 0 girls, the only one of these probabilities that represents 0 girls is this one, where she got a boy and stopped. Now, what about 1 girl? Well, of the ones that are left, getting exactly, and it has to be exactly 1 girl, is this event, which is 0.25. Now, what about 2 girls? It's this event, 0.125. What about getting 3 girls? Well, 3 girls and a boy counts as 3 girls. So that is 0.0625. And what about getting 4 girls? Also 0.0625. And this probability distribution is essentially taking this information and rewriting it in a kind of table format using the variable x to be number of girls.
I guess
Now,
at the beginning, the thing that was kind of confusing me was for A, when you're having to find the probability for each of the simple events in the sample space. I guess that was what, for some reason, was kind of just throwing me off.
Are we good now?
Yeah,
right.
I get it now, 100%.
If you take any probability, including this one, every probability distribution table, what do you think all of these will add up to? Because they always add up to the same number if you did it correct.
Should be 1, right?
Yeah. So if you're doing a homework question or a test question, you want to just have a backup plan, add up all your answers. And if it adds up to 1, that's a really good sign you did it right. If it adds up to 0.8 or 1.7, yeah, things have gone wrong somewhere and you better look at it again.